Right, welcome along to this New Way Growth and ConeX portal, LinkedIn Live. I think we've got a fascinating discussion on this one. I'm quite being a petrolhead and speed freak for my sins. I'm quite interested in this. Sam, did you want to go over and do the introductions? I'll hand over to you.
Yep. Thank you very much. I'll just keep it very brief because I want to get into the conversation as quickly as possible. So obviously, as always, anyone listening along live, feel free just to enter information in the comments. It pops up at our end, so we'll be able to ask the guys some questions. I'm going to start a little bit backwards and introduce Colin to start with. So he designs, builds, makes, creates, whatever you want to call it, sports cars amongst all sorts of other things, mainly the other things, but sat slightly over to his right, there's a very nice looking car, which you would have seen if you saw my LinkedIn post earlier today. So he's a very good person to have on this discussion. Angela has a background in the automotive industry, so hopefully it's going to add some nice valuable insight during the day, and obviously you would have seen Angela on many of our calls. And Raul, who is our guest speaker today, his company Race Software has essentially optimized a solution to support and improve performance of suspension systems, chassis systems, and that kind of makes sense why I've brought Raul and Colin together for this one. These two haven't actually met yet, so I'm hoping this could be quite an interesting discussion between the two of them. So I'm going to shut up and I'm going to hand straight over to Raul and let him talk a little bit about his company, how it operates, his background, history, projects that he's worked on. And I'm sure Colin will want to jump in as and when with all sorts of comments and discussions. So go ahead, Raul.
Yeah, thanks for the introduction, Sam. Thanks for the introduction, Adam. I think, yes, it was quite well what you have presented in regards to our company. And thank you, Angela, and Colin, to make today's meeting. I'll tell you a bit about our company, what we do. And after that, I'll actually keep you some live demos on the go to actually see how we optimize and how we can simulate a complete axle system. I'll share my screen. I'll have a few slides to present. I'll go quite quickly through them. If you identify something, please stop me and ask me on the go. I'll be more than happy to answer to you or at the end of the presentation. Let's see now if I'm sharing the right screen. Should be the right. Can everyone? Oh, nice one. So Race Software, as Sam mentioned, Race, it's actually an acronym from Rapid Axle Concept Evolution. And basically, we are the world's first multi-body simulation software in the cloud. Everything it's done in our platform securely. You can even use the software from your mobile phone device. And also how the software has been engineered. It basically allows you to focus on the engineering aspects of developing your chassis system rather than coding a software in order to get certain results. We have the IP and we can develop any moving mechanism and simulate it. However, we're focused on the motorsport and automotive industries given the credentials that we have. Myself, I've been behind different chassis concepts from Formula One cars to Jaguar F-Type, Aston Martin 177, and other different products, just to name a few. This tells a bit about our company, about our mission and values, and about our team of experts. I think what it's quite key to mention, given the current environment with our software, we also offset your CO2 emissions. And actually outside the UK, it's something that, everyone it's focused right now on it. I can't say necessarily this is our main goal, but given our efficiencies, we are much more lean through our code, and also you have reduced hardware and electricity requirements. This way, reducing your CO2 emissions. How we compare with everything else that it's out in the market, I think we have two key things. Price reduction between 20 to 50x. So we don't speak about the percentage, we speak about an X. So instead of 100K, you'll be looking at 2K, 5K, right? And what can take, even for OEMs, months of years to develop, you can do a full axle simulation with us in the cloud in less than 60 seconds. And that's what I'm going to show you guys at the end. We have different divisions in our team. We build digital twins on simulators. We have an academy with courses, but also with free knowledge and a lot of education that people are accessing from all around the world. We have our engineering services that we help companies to develop their vehicles. SaaS, the software as a service, you go on the platform, in 2-3 minutes, you make an account and you are able to start simulating your suspension system. We have vehicle benchmarking capabilities in-house, but also a database that we have developed through years, and different programs where we engage with universities or racing teams, to name a few. In terms of race programs, this is some of the people that I could fit in one side. I remember Adam was mentioning something about universities and the Formula student teams. We are actually working with a number of universities, actually some of the best in the world. The picture in the background, it's actually University of Turin, who's one of our customers, and they've been used to great success to win our capability and other engagements in Le Mans, in Praga, in radical cars, in India, in top fuel drag racing. And that's the type of programs that we do and engage with different academic institutions, but driver and teams, and all of them to great success so far. We have an academy where people can learn for free all the performance indicators that influence suspension system, but also we have tailor-made courses that people can purchase, and they can learn some things which in our opinion you won't even learn them in the university or even after many years in the industry if you are not around the right people. And we've been working with other platforms as well that have embedded our educational capabilities. Since we've been ranking in Google first with zero marketing searches, that provides the confidence that the world is really keen to learn more from us. The different engineering services that, the different services that we offer. So we do complete vehicle development for our engineering services. As mentioned, because we have the code, we can basically develop any mechanism. And actually we developed with a Formula One team some state-of-the-art technology that it's applicable to other F1 teams, but also to the single seaters. Vehicle benchmarking that I briefly mentioned, we have the capabilities to scan chassis, but also we are building more and more our database, but also given our efficiencies, we are helping the gaming industry with realistic physics. These are just a few of the vehicles, and you can even see the branding from SA Digital Motorsports. They are one of the biggest supplier of sim hardware. XSIM, again, a really great company that supplies all the F1 races. And we basically have brought high-end knowledge from the automotive and motorsports world in order to create digital twins where drivers can develop themselves at a fraction of the cost. I think we improve the safety of the motorsports as well, because once you go off from a simulator in the real car, you can put the same performance, because what we create are engineered models and not immersive models. And actually everyone that has been engaged with us has been winning. And furthermore, this is a case scenario from Le Mans, where basically we acquired the data from the rear car. We have built the initial chassis through our software, and after that we have built the first digital twin derivative on the simulator, obviously taking into account all the other engineering factors like tire degradation, aero mapping, engine, gearbox, just to name a few. Once we had the first derivative, and taking into account what the regulations allow in terms of front and rear setups, we are able through our software to come with engineering reports for each of the front and rear axle setups, build a few different digital twins for the driver to assess. And the fastest setup, we applied it on the vehicle, and that's a real case study how we won in LMP3 with Tommy Foster. So that was a bit of introduction about our company, and now I shall show you the software in action. I'll show you two levels of capability, a standard and an advanced level. Everyone can make an account in 2-3 minutes and start using the capability straight away. For the purposes of the demonstration, I shall show you, I shall preload some previous demo data. With our software, you can import the suspension hardpoints, and this is something that would be quite appealing for calling. You just press a button from whatever CAD software you use, and you import straight away all your suspension hardpoints, which are here, X, Y, Z. This is a 3D live. So for example, if we change this hardpoint, its Z coordinate, you can see straight away the upper control arm inboard wishbone has been, adjusted. So we specified the XYZ coordinates of all the hardpoints. And after, based on our industry knowledge, you have a database of linear bushes and joints that you can select from, for each hardpoint. Yeah, basically for each hardpoint, you can specify the stiffness. You specify your top mount stiffness as well, your damper to suspension system, the rod guide conical, the rod guide stiffness, the wheel bearing stiffness. After that, you specify your topology. So basically, where each link it's attached to, and after that, you have your tuning parameters: spring rate, spring preload, tire loaded radius, and wheelbase. We press submit and run a simulation. The data gets securely packed and sent to our server, probably 3,000 miles away. And in about 60 seconds, we are going to get a full KNC analysis. For the people which don't exactly know what we are simulating right now, this is how it looks in real life. Think about a vehicle that it's clamped, its body is clamped to a base, and the wheels are clamped to different actuators, and we simulate all the physics that you'll see in real life. So vertical, traction, braking, tire aligning torque, steering, and so on. So that's what our software is performing right now. While the standard simulation is running, I'm going to show you an advanced simulation level, and I will walk you through the new things which are added in the advanced simulation. So one of the key things is that we have the anti-roll bar added to the system. And also we have a roll motion test in place. Again, all the XYZ hardpoints are here. If we modify something, it's adjusted straight away. One of the beauties of the advanced is that for each hardpoint, you specify manually its stiffness. So you specify all the 6 degrees of freedom. You specify for how long you want your linear radial weight, and what is the force at the total travel, and for how long you want the total travel. So basically, you specify the linear weight of your bush, for how long you have your linear weight, the total displacement, and the total force at the maximum displacement. This way, we are going to create non-linear splines for each degree of freedom of the bush. And we do that for all of them. And at the end, we have an anti-roll bar rate added, but also we can manipulate for how long we want the steering text. So let's say we want it for 83.2 millimeters, the steering rack movement. Again, we press submit and run simulation. And by now, the standard simulation would have finished. As we can see, we are getting a PDF report ready for manufacturing, but also a CSV report for further co-simulation of data interpretation. Now I'm going to show you the first report, and after that, I'm going to show you the advanced one. So in less than 60 seconds, we get the 50 pages ready for manufacturing report. On the first page, it tells you some details about the user, analysis number, the type of suspension system, the software version, and the date. We have a navigable table of contents, so you can easily skip between pages, a statement of non-liability. And now these are all the tests that we have performed on our server in less than 60 seconds, except the roll motion. As I mentioned, this is a standard entry-level capability, while for the advanced one, we would have done the roll motion as well. So we've done vertical, steering, lateral force, but also 30 millimeters behind the contact patch, braking force, traction force, and tire aligning torque. All these tests are one-to-one to the industry at the highest level. The next pages capture the data that we have inputted in the software, so the XYZ hardpoint coordinates, but also the stiffnesses and the topology and the additional suspension parameters. The following page tells us how long each of the tests took on our server, everything around 48.7 seconds. So I think quoting around 60 seconds, it's the right amount of time. Next, these are the two key things that Colin will find mostly interesting. Where you have two KPI tables, which basically represent the performance indicators of your axle system. All of them are backed up by graphs. So for example, if you want to understand the feeling that you have through the steering wheel, we'll be looking, let's say, at the bump steer on center. We press on it and we can go and see the full spectrum graph for complete analysis. So we have our KPI tables or everything static geometry related, steering input, vertical motion. And after that, we go into the compliances. So we understand the different parameters for the braking force, lateral force, traction force, tire aligning torque. All of them, as mentioned, were backed up by graphs. And it's very easy. You click on one of them and you go straight to the next one. I'll just scroll a bit quicker through this report, and after that I'll go to the advanced report. And the last page of the report, it's the KPI sign convention. So you know the units, you know what's towing, under braking, and so on for each of the metrics. Let's take a look if the advanced simulation finished. Yes, it has completed as well. Probably to be just slightly over 60 seconds, but I believe still it's quite quick for something of this level. We have a slightly bigger report. It's 70 pages because we have specified all the stiffnesses at each of the hard points. And I'll only focus now on the additional things that the advanced report has in comparison to the standard report. So in addition to all the tests performed, we have done also the roll motion test. So all the tests that you see on this report have been performed. Again, we captured the XYZ coordinates, but something which is key and quite interesting is the fact that we specified all the 6 degrees of stiffness for each point. So if we want to see the stiffness at point 1, we click here and we can see exactly all the curves that have been generated as a stiffness at that particular point. Of course, you have full manipulation. You can make a ball joint, or you can make a completely non-linear snubbed joint based on your design. And actually, I will show you how the bushes influence the performance of the suspension system. As mentioned, we did a custom steering rack test at 83.2 millimeters. It took just slightly over 60 seconds, everything on our server. And now we go to the 2 KPI tables. We have the roll motion as well added. Again, all of them were backed up by graphs. You click on one of them and you can understand the full spectrum. And to see the influence of the non-linearity of the bushes, let's, for example, take a look at the brake steer. And we can see in the initial rate, everything is linear. But when the bush is actually snubbing, your complete brake steer, it changes, as you can see, into a non-linear spline. So that would be I would say a bit of presentation about our company, but also how our software works.
Fascinating.
It is, isn't it? It's all about the fact that you just put a 70-page report out in about 60 seconds is mad. I'll let Colin and Adam jump in if you've got any comments. Colin being the
I want to meet the guy that writes those reports.
It's actually something that has been developed for years in order to be able to do everything, as you can see, automatically. So there is no guy, probably there is a small fish in the ocean doing it.
It's a man inside your computer, isn't there, writing it in that 60 seconds.
I was expecting somebody to
And
pop in and say,
actually,
"Oh, it's
the
Chat
servers are
GPT."
about,
So when the computer
and
says
actually, the servers are about 2,000 miles away. So we did in less than 60 seconds, 4,000 miles as well.
that's multi-talented. I like him. He's a good guy. So I think for me, the thing that really highlights what probably one of the key points that this software is doing is when you demonstrated those cars sat on those platforms. Generally speaking, those platforms are set to simulate road or track environment or even off-road environment, which then actually sends signals right the way through the chassis. And that equipment and that sensory equipment is worth millions to most people. So what seems crazy is that, you know, this is £1 million software.
So indeed, to do a physical test, it can be probably over 10,000 pounds. But even if you do a physical test, then you can come back to our software and you can do 1,000 simulations in 1 week, and the cost starts from £50 a month, unlimited simulations. So the level of development you can do virtually with our tool, it allows now everyone who's under a high-end OEM or an F1 team to have this capability in order to, like yourself, Colin, someone who builds a kit car or something like that, they would have had to spend, I don't want to say competitor license prices, but they are from 4 digits upwards, and you need to focus on coding, while with this software, you can even take it from your mobile phone, change a hardpoint, and see all the performance. And the beauty of the software is that each of the key performance indicators that you've seen, they're backed up by knowledge on our platform for free. So if you don't know what camber compensation is, we tell you straight away, very concise, and with examples from the industry.
Yeah. So to get to where we got to, a lot of our stuff was based on knowledge to start with, to what's right and what's wrong, and then going from there. But what happens is when you get all of those other things starting to play a part, camber compensation or whatever, or hard cornering, or what happens when you're under hard cornering and heavy braking or acceleration, everything changes. Those are all situations where things are different, and the only way to find out if something's working is to get out there and use it. So you find yourself on racetracks, you find yourself sprinting, hill climbing, doing whatever you can in a variety of different locations. And it's just like trailering, moving, people, time, fuel, resources, tires, which are expensive and getting more and more expensive every time. So all of that gone.
And I think one of the beauties of the software is if you start to do everything hands-on and you start to modify, let's say, your mechanical trail, right? So you focus on your caster trail as an example. Actually, when you focus on optimizing that, you are actually influencing many other KPIs that you won't be able to capture if you actually don't have one of these reports, because you can impact, you have anti-dives, for example, while you're focusing on something else. So you always need to have an educated decision for the changes that you make, and also how they affect the other parameters, and have a full-rounded, engineering and interpretation. But at least you can do, loads of unlimited simulations, and at the end you can put the perfect setup on the vehicle. And that was a similar case scenario with us in Le Mans. They had 4 different setups at the front, 6 different setups at the rear. So we were able to back with engineering reports this, but also we were able to build on the simulator the car before you actually even apply the setup, and see the performance from the simulator, and use the simulator also to train at no cost.
Raoul, based on that, from what you were talking about there, from the Le Mans point of view, for the people that are listening in, they're interested, from a performance point of view, what was the saving from a time performance?
So from a time performance, I wouldn't be able to specifically say what would be the difference compared to a previous setup that they would have used and a new setup. Actually, this has been quite a while back. However, what I can tell you for sure and actually be backed by the specific Le Monde team is that I managed in 5 minutes to show them something that they were trying for more than 3.5 years. So I'll be speaking from an engineering performance point of view, from an actual time savings. I can give you an example at Silverstone with a different vehicle, with a Praga R1. So on a 2 minutes lap, the difference between the simulator and real life for the same driver, same conditions, has been of 0.08 seconds. But when we build a digital twin, we take into account much more things than just that you've seen through our software, because we need to build the tire degradation, the engine mapping, the aero mapping, so there are a few more factors that go into it. But we bring knowledge from, let's say, 25 million pound simulators to something which is a bit more digestible to teams that don't have that specific budget, which is most of them if you are not in F1. I mean, all of them, I assume. So hopefully I managed to give you a good feedback, Adam, even if I can't remember exactly by how much we won in Barcelona.
No, that's good. That's good. Sorry, Sam. The other question I was going to ask now was, we got 4 wheels there. What about 2 wheels?
It's very interesting because back in the day, I think I created one of the fully parameterizable 2-wheeled vehicles with wider dynamics, and my competitor, which is now actually has awarded with me at the 50th anniversary alongside a few prolific companies like NASA, Magna, and so on. But to give you the right answer is maybe it's something in the future that would be looking at. Currently, the automotive and motorsport markets, in comparison to the 2-wheeled vehicle markets, they are way more evolved. So before we run, it's better to walk and to support the bigger market. But yes, in the future, we would be looking at doing two-wheel vehicle simulations, but it's down the line because it requires a lot of development. And what you have seen here in 60 seconds, it's many years of development,
Okay, yeah, but you can apply those same sort of like principles and everything like that. You just got to do the development work into a 2-wheel side. Right? Yeah.
Indeed, but we need to take into account that you have the gravity, and when you have 4 wheels sit on the ground. When you have 2 wheels, you need to create smart controllers in order to adjust the bank angle of the rear wheel versus the torque at the steering wheel. And on top of this, you have a dynamic factor, which is the human. The human, it's like a bush, like I showed you, like the 6 degrees of freedom. And how do you control the human, right? So it's different. In a car, the human doesn't have any input from a mass perspective that much to bring inertia. While with a motorbike, it's a totally different game.
Yeah, that's what I was thinking about. Was the variables going into the shift of weight across the seat, sticking the leg out, or sticking the knee out, and then sticking the leg out under braking as well, going into a corner and things like that. And that's what I was thinking about, is the amount of variables going into it. It's fascinating.
I think as well, it's not just about the movements. I mean, a motorbike, you practically become more motorbike when you ride it. But then you've got to think on top as well, is the weight of the rider. Surely that needs to be taken into account as well. So a lot of variables there.
Yeah, definitely. I'm not gonna quote the figures because I'll get this wrong. But Raul, what was the race in, was it Barcelona with Tommy that you did supported with his kind of co-driver, and you brought his co-driver up to speed just using simulators, and they were knocking out similar times?
So yes, actually Tommy Foster, it's an in-house development driver right now. been working with us for quite a few years right now. And the case scenario that you're speaking, it's the Praga R1 digital twin that we have developed. And in Praga, you have two drivers. You have an amateur driver and a pro driver. Tommy was the pro driver, while Miles Lacey, he was the amateur driver. We basically put both of them 2 days before the race on two simulators, and Tommy was able to help Miles to level up and push the boundaries in his head, where to brake, where to turn. And based off the simulator results, Miles had one of the fastest time of the day, and he was getting complaints from the other drivers that he wasn't an amateur driver, but all the work came just from the simulator. And actually, Praga was very nice, and they did quite a nice video, which is on our platform and on their platform as well. And actually, they managed to beat the best sim racer in the world, who came second, which for us, which don't come from a sim perspective, it's something, which brings a lot of confidence. However, a lot of respect for the driver that came second. Actually, he was able throughout the year to have a much better team and progress further in comparison to Tommy or Miles. But yeah, that's a true case scenario that we presented in the ADAC Sim Racing Expo last year, which is the biggest Sim Expo event in the world in Germany. And yeah, we've been leveling up a few drivers in GB4. We've been working with a driver as well. We've been developing the winning car, and yeah, these are just a few case scenarios.
Brilliant. I'm going to pick on Colin slightly. Have you got anything upcoming race-wise? Anything planned for your car this year?
Yeah, there's a couple of things happening this year, possibly starting as early as March. It might be a little bit delayed. But yeah.
Keeping it under wraps, are we?
Yeah, for a minute. It's I've got some ideas. What I'd like to do, actually, first off, because I've just noticed that Roll said something about just putting in hard data. So we do have the CAD for the entire chassis dynamic. So it'd be interesting to actually put that CAD into the software and just throw out what we should be doing and seeing if it's anywhere close to what we are doing. I think as a first port of call, I think that would be the most interesting thing to do. You might tell me that my wheelbases are wrong, my tyre sizes are wrong. I don't know. Yeah, I don't know. Is there a little magician in there that tells me, what size calipers I should be using? But,
I assume from the CAD package that you have, we just need to export the files and we can import them second via CSV. And I assume you'll be probably running poly bushes at 20 kilonewtons per millimeters or ball joints at around 50 kilonewtons per millimeters. It's just my initial assumption, knowing how the kit cars are built in a way. But yeah, we can obviously do that, and it would be quite quick.
Yeah, no, that'd be a nice little exercise just before we do anything, just to dial that information in and just see what it spits out. That'd be nice little exercise.
So to give you
make a case study
an
out
example,
of
we actually with one of the clients that we can speak about loudly, and the vehicle now went into manufacturing. We re-engineered from scratch the Jaguar E-Type chassis. So now it has a space frame structure with double wishbone engineered front and rear suspension systems using our software, with a custom Titan steering rack and custom AP racing brakes. All the CAD, FEA, MBS tools that are currently at the highest level in the industry have been used to re-engineer the E-Type, and soon there will be an article published.
Very cool.
Superb.
So where we are able to support anyone from an individual to a high-end OEM. Obviously, for individuals, we are bringing unseen capabilities extremely fast and cheap, and for OEMs who are helping them to get the products quicker to the market, while empowering both the CAD and the simulation team with tools that previously they couldn't use concomitantly. So now a CAD user can use our software instead of going back to the simulation user and ask him, can you please run me these hard points? Now the simulation department can set the targets and let the CAD guys focus on developing the CAD hard points, while the simulation guys focusing on improving the engineering performance.
Yeah.
While saving costs.
Yeah. Less hang-ups. Yeah. I like it. It's very cool.
Brilliant.
Yeah.
We'll,
I look forward to what comes next out of this meeting, because I think I'm quite excited already just to sort of like see what the information says about what we are doing already. Even before we actually put it anywhere near the car, I think maybe we should just literally just do it from the CAD and find out that we're find out if we're doing how wrong. Sorry, I'm not going to say if we're doing it right. I'm going to say how wrong we are. So yeah.
I don't think there is a right and wrong. So always
it's going to show. It's going to highlight
where you want to put your vehicle.
Yeah.
Yeah.
I mean, it depends how you want your vehicle to behave. You want to be, to behave like a Peugeot 206, or you want as an, F1 car. Obviously, the targets will be slightly different.
So when we were developing the car, there was some stringent like rules that we set ourselves. So arguably a lot of cars in this industry, well, not in the bespoke car industry, but certainly you've mentioned kit car industry a few times, you tend to have what I call sort of mediocre suspension setup. So it's kind of like, there's this mentality that the stiffer it is, the better it handles, whereas obviously that's not true. Not all the time. What it doesn't do is it doesn't make a nice road car and track car. It'll either make a very good race car because it's been set up to be safe and it'll handle a circuit very nicely, where the road doesn't undulate so much and there aren't potholes every 5 minutes, and those potholes are growing in quantity these days. But what I was looking at, let's not go there. So what I was looking at when I was developing this car was that it is a road car. Even if somebody buys it with the full intention that they're going to take it to a track, the chances are that maybe they'll visit the track once a year. So 90%, 99% of the time spent in this vehicle is still going to be road based. So compliance was a big point in the development of the Tonic. So we were looking for compliant suspension that was easy to manipulate to actually tune when you get to the circuit. So we did that on valving on the dampers. So we'd maybe like just do 2 or 3 clicks just to stiffen it up, drop a few degrees out of a few PSI out of the tires, and away you go. So
I think my business partner would have a really benefit from that, Colin, because he used to drive on a daily basis a Caterham, and he drove in 8 months just under 20k miles. So 8 months, just under 20k miles as his daily car, and as an outcome, his back it's not very well right now because he didn't have all the compliance into the vehicle, so his back had to take a bit of a hit.
Yeah, that's exactly it, and that's one thing that we really focused on when we were developing the chassis on the Tonic, was compliance. And that's actually the feedback that we do get every time somebody does drive one of the cars, is that, oh, wow, nowhere near as hard as they expected it to be, and yet the car is always on the ground. It's very planted. So even when it's light, as you go over undulations, because the suspension is designed to travel, it maintains grip even on high spots as the weight comes off the car. So we think that we've done a good job, but you're going to tell us different, I expect.
I think everything it's very fine tuning. Just to give an example, if we modify the outboard tie rod joint vertically by a few millimeters, let's say 10 millimeters, right? That's just 1 centimeter. That it's about 15 degrees per meter of your bump steer. You can go from a negative bump steer gradient to a completely positive bump steer gradient. And what does this mean in real life? For just 1 centimeter height difference at the tie rod, you can have a steering feel completely out of the vehicle. So
Yeah.
I think that's the beauty of the software. We are able to do it down to the millimeter and get all the front axle and rear axle flavor to combine and give you that feeling that calling it's after. Of course, the next stage is to focus on the bushes and to build the right compliances. So when you go under braking, you have certain compliance. When you have traction, different compliance, but also laterally. That's why we need to engineer all the 6 degrees of stiffness at each particular hard point. And this is already high-end OEM level.
Yeah.
Well, yeah, I feel like we're going into a very in-depth discussion here. We'll start to wrap this up, and I feel like Raoul and Colin, you need to go and sit down for like 6 days and carry on talking, because I feel like you can. So we'll bring this to an end. I don't know if Adam or Angela, you wanted to throw anything in at the end, and we'll wrap it up from there.
No, fascinating conversation. It's good.
Absolutely. Yeah, I agree, Adam. Yeah, absolutely fascinating. I could have sat here for another hour listening.
Yeah, brilliant. So this will be available to watch back, obviously, from Adam's page, this link, and we'll put it on YouTube as well for anyone who wants to watch this back. And yeah, that's kind of where we're at. So I'll leave just by saying thank you for listening, and thank you for Raoul, obviously. Thank you for Colin for joining us, and we'll see you again at the next one next month.
Thanks, son.
Thanks, bye.
Yeah, thank you very much, guys. And
Bye.
yeah. Thank you. And Sam, now you